Hey guys, we are going to learn a second way of doing polynomial division. I think you're going to end up liking this one better. As you go through the process, there are no x's that you have to worry about, just numbers. So it makes it a little bit easier for most people. The only slight complication with synthetic division is it can only be used if we're dividing by a linear factor instead of a quadratic or anything higher. So that's the only stipulation that you have. So if we are taking, in this first example, this cubic, and dividing it by x minus 1, what you're doing is, remember, this is kind of like the factor that you have. And when we were graphing polynomials, if we had the factor at x minus 1, that means your root is really at x equals 1. So we have the x-intercept of 1, 0. So we're going to take that root and put it off here into a little box. And then what we're going to do is take all of the coefficients that you have in the larger polynomial that you're dividing into. So the coefficient on x cubed is 1, negative 3, positive 6, and negative 4. Write those out in a line and leave some space and draw a line. This is how you set up a synthetic division problem. And it's going to be a series of multiplying numbers and then adding numbers. So you're going to always start by bringing the first number down. So we're going to bring down the 1. And you're going to start by multiplying. You're going to take 1 that you have here and multiply it by the 1 in the box. So 1 times 1 is 1. And you're going to place the answer in the next block over from where we were. Negative 3 plus 1 is negative 2. Then you're going to take, so we multiplied, we added, now we multiply again. Negative 2 times 1 is going to be negative 2, so I'm going to add that right here. Now add down. 6 minus 2 is 4. We're going to multiply again. 4 times 1 is 4, and we're going to add down. Now, this is what we are looking for. We are looking for a remainder of 0, which basically means this factor went in perfectly. There was no remainder. It's a perfect divisor into this larger cubic. So think about, I have x to the third and I'm taking out an x. So I have x to the third and I'm taking out an x. What does that power go to? It goes down to a quadratic. It goes down 1 degree. So what that means is these new coefficients that I have are your coefficients of your polynomial 1 degree less. So this would be 1x squared minus 2x plus 4, and that's your answer. And we don't deal with x's at all during the process of the problem. So if we tried another one, even if it's set up originally like this, what we're going to do is we're going to write it in this box. If x plus 9 was our factor, we're checking to have a root at negative 9 then. And we're going to write down all of our coefficients in line. You are going to always bring down the 1, or whatever number that is actually. You're just going to bring down the first number. 1 times negative 9 is negative 9. Add down, you're going to get negative 8. Negative 9 times negative 8 is negative 72. No, it's not. It's positive 72. We're going to add negative 72 plus negative 74 plus 72, and I'm going to get negative 2. Negative 2 times negative 9 is a positive 18, and I can tell right away that that's awesome. I'm going to get 0, which means these are your coefficients for your polynomial 1 degree less than x to the third. So x squared minus 8x minus 2. And that's our answer on that one. Okay, let's try another one. So if we're dividing by x minus 1, that means our root would be at the opposite. So our root, I don't know what I just drew. Our root would be at 1. So our coefficients would be 1, negative 8, 15, and negative 11. So I'm going to bring down my 1. 1 times 1 is 1, so I have an add 1 there. Negative 8 plus 1 is negative 7. Negative 7 times 1 over here is negative 7. 15 plus negative 7 is 8. 8 times 1 is 8, and I see that I'm getting a number and I'm not getting 0. That means that this is the remainder. And these three are still your coefficients of your polynomial that's 1 degree less. And if you remember from when we did long division, we write our remainder over what we were dividing by. So you're going to then have negative 3 over x minus 1. This is quicker, I think, if you are trying to find the other roots, if you're given one of them. So what I have on the board, we have a cubic. It is not factored, so we don't know all of the roots. We do know, I'm going to give you the information that we have a root at negative 1. So if the instructions say, find all the other roots if one root is given to you, you know that that root is negative 1. So we can do synthetic division. This is probably quicker than long division from the other day. We would have negative 1. We bring down our our coefficients. And it's nice because I actually know this one should work out because I'm telling you, you have a root at negative 1. So you should be getting 0 over here. If not, you've done something wrong. So 1 times negative 1 is negative 1. Add negative 1 and negative 1, we're getting negative 2. Negative 2 times negative 1 is positive 2. Add negative 10 and 2, and you're going to get negative 8. Negative 8 times 1 is positive 8. So I did get the 0 that I needed. That means I have x squared minus 2x minus 8. And at this point in time, it's knocked it down to a quadratic. And we can do what we've known from quadratics. You can use the quadratic formula. You can use factoring if it's factorable, or you could use completing the square technically to find the other two roots. And I know that I have 2 because I started with a degree of 3, and you're going to have 3 answers then. So I have a quadratic that actually is factorable. So this one's kind of nice for us. It's going to factor into x minus 4 and x plus 2. That means I also have a root at 4, and I also have a root at negative 2. The biggest thing that you need to get out of today is how to set up synthetic division, though. I think it's a little bit easier than what we did the other day. So hopefully that helps a little bit.